Okay, so now we will see algebra of complex numbers. So algebra of complex numbers, first is addition of two complex numbers. How to add the two complex number? Addition of two complex numbers. Okay, so two complex numbers can be added. Their parts, their real parts and imaginary parts are added separately. For example, if we have a complex number z1 is equal to a1
Sir, your
plus
voice is
iota
cutting.
b1 and another z2 is equal to a2 plus, yes, iota
Your
b2.
voice, sir, it's cutting. It's lag.
Okay, okay. Okay, that is from because of some network issue it will come now. So then we have to find the sum of these two numbers. That means Z1 plus Z2. So when we are adding these two numbers, A1 plus iota B1 added with A2 plus iota B2 or B2 iota, same thing. Okay, there we write first. Now here what will happen? We have to add the real part and imaginary parts separately. A1 will be added with A2 and obviously I will be common and B1 will be added with B2. So there is nothing new in this one. We are adding the like terms. Correct. So for example, if we add 5 plus 3 iota is added with minus 6 plus 7 iota. So we can add 5 minus 6 will be written together and plus iota is common, 3 plus 7, 7 plus 3, 10. So it will become 5 minus 6, that is minus 1. 7 plus 3 is iota 10. So 10 iota. So I will write minus 1 plus 10 iota. Okay. So this is the addition. But we should know the properties of addition. Which are the properties followed by the complex number? So properties of addition of complex number. Properties of addition of complex numbers. Here first is it is followed by closure property is followed by the addition. Closure law means we can add in any, means Z1, if Z1 and Z2 are two complex numbers, their sum is also a complex number. This closure property says that if Z1 and Z2 are complex numbers, then it implies that their sum will be a complex number. Z1 plus Z2, it is also a complex number. It's also a complex number. Means sum of two complex numbers is a complex number. Second property is commutative law. Commutative law means commutative law. Commutative law means we can add in any manner. Means if we add Z1 plus Z2, means if we add Z2 in Z1 or Z1 in Z2. So we can change their order of addition. That is followed here, commutative law. In associative law is also if you have three complex numbers and you can add in the different order, means if you are adding Z1 plus Z2, first you are adding Z1 plus Z2 and then adding Z3, or you are adding Z2 plus Z3 first and then is added in Z1. So we can change. Then fourth is existence of identity. Identity is an element which is unique element in every set, which can be added in any number. It will not change the number. So that is called additive identity. So like additive identity is zero in other numbers. So here also the additive identity is zero complex number. Okay. So zero is an additive identity, 0 plus iota 0. This is called additive identity. And additive inverse means if for each and every element there is an element which can be added in that to give the additive identity. Means on adding will give you the 0, that is called the additive inverse. So in additive inverse we can have opposite number if we add. Suppose additive inverse of every number exists. Suppose you have 3 plus iota 3 plus 2 iota. So you can add in this one minus 3 minus 2 iota to get 0. So minus z. If it is z, this will be minus z. So for every there exists a negative complex number. For every complex number z, there exists. This is the symbol of there exists. There exists a complex number. There exists a complex number minus z such that their addition means z plus minus z is equal to 0. So for every number there should be a number which can be added to give the 0. Here 0 because 0 is the additive identity. Okay. So this way we can add, and subtraction is also the same thing. Some subtraction is the addition. We can say the subtraction of two complex numbers is same as z1 minus z2. Z1 minus Z2 is actually Z1 plus sum of minus Z2. That's why we are not going through the properties, because this is following the addition. So it will follow all the properties of addition of complex numbers. So Z1 plus Z2 you can subtract. So you can write the values. Suppose this is A1 plus iota B1 minus plus minus minus, you can write directly also A2 minus iota B2. So their real part will be subtracted separately and imaginary part will be subtracted separately. That's all. Multiplication. Now we have some questions. Express, then we will start multiplication. Express in the following. Express the following. Express the following in, this is called standard form, in the form of a plus iota b. Means we have to solve and get it iota in the numerator. If it is in the denominator, we have to multiply, divide to bring it into the numerator. The question is, we have given 1 by 3 plus 7 by 3 iota plus 4 plus 1 by 3 iota, and it is subtracted from minus 4 by 3 plus iota. This we have to solve. So this is the addition. So first we will add. So 1 by 3 will be added with 1 by 4. Sorry, 4. 1 by 3 plus 4. And iota is common. So 7 by 3 plus 1 by 3. This is the first bracket. Second, as it is, you can multiply minus 4 by 3 minus iota. So 3 4 are 12, so 13 by 3 plus 7 plus 1 8, 8 by 3 iota minus 4 by 3 minus iota. That means we can write 13 by 3 minus 4 by 3 real part together, and imaginary part is 8 by 3 minus 1. So 13 minus 4, 9 by 3, 3 is a 9, 8, 8 minus 3, 5 by 5 by 3 iota. So 3 plus,
So wouldn't it be 9 by 3?
this will be plus, sorry. So this will be plus, so then we will get 17. We get 17 here, 17 by 3, correct? 17 by 3 plus 5 by 3 iota. So this is converted into this form, a plus iota b. So like this we can convert. And another question that you can try by yourself for practice. Second question is for you. That is 1 by 2 plus 5 by 2 iota minus 3 by 2 iota plus minus 5 by 2 minus iota. This is your homework. Okay. So sometimes we have to find that we have seen before also. We have to find the unknown values. Now we will see multiplication of two complex numbers. Multiplication is simple actually. You know the multiplication of the iota. You can do simple multiplication. Multiplication of two complex numbers. Complex number. So multiplication, suppose Z1, you have to multiply with Z2. Okay, Z1 is A plus iota B, and let Z2 is C plus iota D. Either you can go through the multiplication, simple multiplication, multiply A with C. So this will become AC plus AD plus AD iota, then multiply B. So this will become iota BC, and plus iota 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 square and B into D BD. And you know that iota square is equal to what? Minus 1. So this will change to minus 1, and this will become real part. So therefore, we get AC minus BD, AC minus BD plus iota AD plus BC. So this is a simple multiplication, and it follows all the laws, closure law, closure law, that multiplication of two, closure law, follows the closure law, commutative law of multiplication means you can add in any in multiply in any order. Z1 Z2 will be equal to Z2 Z1, Z1 Z2 will be equal to Z2 Z1. Here closure law means product of two complex number is a complex number. Associative law means you can change their multiplication. First you can multiply Z1 Z2 and then Z3, or you can multiply Z2 Z3, Z1 Z2 and then multiply with Z3, or you can do Z1 and multiply Z2 Z3 first. So that is existence of multiplicative identity. Multiplicative identity means the number which when multiply with all the numbers will give you the same. So that is multiplicative identity is 1 here, because 1 means 1 plus 0 iota. When you multiply with 1, nothing will change. So that is multiplicative identity. Multiplicative identity. This is I for here identity. then multiplicative inverse. Multiplicative inverse means the number which when multiply with the given number to give you 1. That is multiplicative inverse. So that is also reciprocal. So if Z1 is a number, then when you multiply Z1 with its inverse, Z1 inverse means 1 by Z1, then you get 1. So this is called the multiplicative inverse of this number. So we can find out easily by solving. For example, and distributive law is also followed here. Distributive law is also followed. Distributive law means Z1 is distribution of multiplication over addition. Z1 plus Z2 into Z3 will be equal to Z1 Z3 plus Z2 Z3. Like this, the law is followed. And now multiplicative inverse we will find later on by some other formulas also, multiplicative inverse. But as of now, we can do by simple calculation. Let's take, suppose Z is a complex number b minus 7 iota. Okay, so here a is what? 3, b is what? Minus 7. Okay, so we can do by other way, or we can find 1 upon z. Actually, if z we are taking a plus iota b, and we have to find z inverse. So z inverse will be 1 upon z. 1 upon z means 1 upon a plus iota b. And 1 plus a plus iota b means we have to multiply by 1 minus iota b, a minus iota b, a minus iota b. As you know that this is a square plus b square. Denominator will become a square plus b square because iota square is 1. And it will become a minus iota b. So by this way we can say that a upon a square plus b square minus b upon a square plus b square iota. This is the inverse. So directly they have put this formula. To find the inverse, we can put this formula also, or we can solve. Either we put a and b, and then we can write directly z inverse is equal to a upon what is a? A is 3. 3 upon 3 upon 3 square 9 plus 7 square is 49 minus d, that is minus 7 upon 9 plus 49 iota. 3 by 58. 3 by 58 minus minus plus 7 by 58 iota is the inverse of this one. But if you want, you can do like this: z inverse, then 1 by z, and 1 by z is 1 by 1 plus 1 minus 3 iota, and multiply and divide by the opposite. 3 plus 7 iota, 3 plus 7 iota, and then you can get the same result, because this will become 3 plus 7 iota, and the square of 3 is 9, 7 is 49, 49 will become 58, so 3 by 58 plus 7 by 58 iota. The same thing we can find by this way or that way. Okay. Now there are some other questions also, expressing in the form, find the values, that we will do. Now we have division of complex numbers. So division of complex numbers is also not having some special properties, same that we are following the properties of a complex number. The division of two complex numbers, we divide z1 divided by z2, we can write z1, and it is also can be written z inverse, means it's inverse. So this is product. So product rule will be followed. For example, we have to find, suppose question is express how we will find -2 minus 5 iota divided by 3 minus 6 iota. Express in the form of, means simplify in the form of a plus iota b. So dividing, so divide -2 minus 5 iota is divided by 3 minus 6 iota. Simple division, as I told you, you have to multiply and divide by its conjugate. That is called conjugate. We will study when we change the sign of a imaginary part, that is called conjugate. So 3 plus 6 iota, multiply and divide by 3 plus 6 iota. Numerator, this is -2. So -2 into 3 minus 6, and minus 6 to the 12 iota. Then minus 5 3 the 15 iota. Then minus iota square 5 6 the 30. Divided by 3 square 9, 6 square 36. 36 and 9, 45. So this will become minus, iota square will become -1. So minus minus plus 30. 30 minus 6, 24, and 12 minus 12 minus 15, 27 iota divided by 45. Divided by 45. So we get 24 upon 45. 24 upon 45 minus 27 upon 45 iota, or it is converted into the, can be cancelled. 3 8s are 24, 3 1s are 3, 3 5s are 15, 8 by 15 minus 3 9 9 3s are 27, 9 5s are 45. So we get the result. This result is simplified as this one. So we can write 8 by 15 plus iota minus 3 by 5. So you have to do these questions, extra question number 1, question number 2, and exercise 5.1. Okay.